Alright, here we go. This is Chapter 11 review. This is just the quiz. Remember, we only had 10 questions, and we just took this pretty recently, so it should be a little fresh in your mind. So let's go through question by question, and that should be it for everything for the final exam. Alright, let's see what we're going to do. We're finding the area of this parallelogram. So the area of a parallelogram, I'll put area, equals just the base times the height. Alright, if you take a look at this, this would be the base. If you want to think of it down here, you can think of it down here as well. But what is the height? The height is not the 9. The height is the perpendicular distance. Let's just take it from there, and we'll call that the height. So what we have now, it's perpendicular, so it's a right triangle. So now what we can do is we can solve for the height. So we know what the base is. It's 12 from here to here. But we want to now find the height. So let's do that. Just use a little trig function. Well, you could use trig function, or you could realize that it's a 45, 45, 90 triangle. Okay, and the hypotenuse is the square root of 2 times 1 times one of the legs, or you could divide it. So you could take 9 divided by the square root of 2. You could just do that. 9 divided by the square root of 2. And you could just say that's the height right there, because we're going to write it in decimal form anyway, so you don't really have to rationalize the denominator. You can just keep it like this. So what is the base? The base is 12. The height is 9 divided by the square root of 2. You can just plug that all in the calculator. Once you stick that in a calculator, you should get 76.4. It's area, and it's in inches, so it's inches squared. All right, you could do it that way, or if you wanted to, you could do the trig function. You could go opposite over hypotenuse, which is the sine. So you could say the sine of 45 equals the opposite, which is the height, opposite over the hypotenuse. Multiply both sides by 9. You can throw that in your calculator, multiply that by 12, and you should get the same exact thing. I really don't have a preference on how you do this, but either way, it'll get you the same answer. This problem is very similar to the one we just finished doing, except they tell you the area this time. They don't ask you for the area, they tell you the area, which is 187. So remember, let's write the formula down again. The area equals the base times the height. And what do they tell you? They tell you the area, which is 187. What else do they tell you? It says find the base x. So we'll call, however you want to do it. You can put an x right there if the height is 11. So the height you can put right here. Alright, so really, it's as simple as that. You just divide both. Remember what we're doing. We're solving for, let's see, why did I put the height as h? Don't know. But the height is 11. Alright, and we're trying to solve for the base. That says find the base, x. So we're solving for x. Divide both sides by 11. Divide this by 11. You throw that in a calculator, and it's 17. By the way, I'm just thinking of this. Do you know how to multiply by 17? Or multiply by 11? Watch. If you have 17 times 11, you go 1, 7, you split it up. Watch, you add up the digits. 1 plus 7 is 8. Stick it in the middle. There it is. Isn't that cool? So anyway, just was thinking of that since I saw the 11. So you could actually have gone backward. You could have said, oh, 1 and 7 are split. They're added up. It's an 8. So if I divide this by 11, I get 17. I don't know. Or you could use a calculator too. All right, let's move on. Alright, they give you no picture on this one, but if you just know the formula, you should be good with this. It says the height of a parallelogram is 1/3 its base. So let's write that. The height is equal to 1/3 its base. You can put 1/3, or you could put base over 3. The height is 1/3 its base. If the area is 363, so remember what the formula is? It's this. So let's stick in 363 for the area. It says find its base and its height. So what is the base? Well, the base is just b. We don't know what it is. Do we know the height? Yeah, we kind of know the height, don't we? It's what? It's base over 3. So you can go ahead and solve for this. Watch, 363. A couple ways you could approach this. This is one way. B times b is b squared over 3. Let's get rid of the 3. We get rid of it by multiplying both sides by 3. So you take 3 times 363. And I believe that's 1089. 1089. And that equals b squared. I'm just going to put it over here. I like it on the left-hand side. So it's 1089. Take the square root of 1089. So b equals, watch, get rid of this by the square root, get rid of that by the square root, and so that's going to give you 33. So the base is 33. Well, that's one thing. What does it say, though? Find its base and its height. Well, remember what the height was. The height was a third of the base. So the height is just that base divided by 3. So the height is 11. So we can just go strictly on our formula. You had to realize what was going on right here, that the height is 1/3 of the base, or the base divided by 3. Plug the stuff in, work it out, and there you go. Alright, we're going to a different figure. It's not a parallelogram this time, it's a kite. And we remember the formula for a kite, I hope. So the area of a kite is equal to 1/2 the product of the diagonals. Alright, so where are the diagonals? If I was to draw the diagonal, tell you what, oops, daisy. Let's just put that in a different color so it doesn't get mixed up. Alright, so that would be one, and that would be another. Alright, so there we go. So there's the two diagonals. Now, if you look at how I labeled them, from D to B is 13, so that's the length of one diagonal. And then from A to C, see that lines up with the A, this lines up with the C, that would be the other diagonal. So it's just a matter of just putting the numbers into the formula. That's all there is to that. So it's 1/2, one diameter, times another diameter. So it's 8, 1/2 times 8 times 13. You just put that in there, and half of 8 is 4, 4 times 13 is 52, and it's just 52. I'm not going to take off if you don't put this, but it doesn't tell you what units, it doesn't tell you inches or centimeters or anything, but a lot of teachers would have you do that, 52 units squared. That's how you find the area of a kite. Alright, here's a different form. It's not a kite, it's still a four-sided figure, quadrilateral, but now it's a rhombus. Okay, now we also have a formula for rhombus, and it just happens to be the same thing as what the kite was. It's 1/2 the product of the two diagonals. So AC would be one diagonal, DB would be another diagonal, and it's 1/2 the product of those two numbers right there. So let's see what they give us. This time they give us an area. They don't just give us the diagonals. They do give us the area and one diagonal. So the area is 126. I'm going to write that down. Equals 1/2 times one diameter times another diameter. Well, DB is a diameter, so we'll just call that 18. And find AC, that's the other one. We'll just call it D. We'll just call it D for diagonal, or we could call it AC if you wanted to. Alright, so let's do this. Well, let's do some math. It's pretty easy. Half of 18 is 9. Divide both sides by 9. So 126 divided by 9. Let me see. Hang on just a second. Okay, I couldn't find out where I put that, but that is equal to 14. Sorry, I couldn't. Oopsie daisy. I couldn't do that in my head, but it's 14. So AC, which is the other diagonal, is 14. So rhombus, remember rhombus, all four sides are equal to each other. If all four sides are equal, it's 1/2 the product of the diagonals as well. Now, a rhombus is still a parallelogram, so you could still go base times height. The only problem with this is I didn't know the base and the height. So if you don't know the base and the height, hopefully they give you something about the diagonals. And they did. They told us the area and one diagonal, so that means you could find the other one as well. Let's go to number 6. Okay, number 6, we're getting away from quadrilaterals, and this time we're finding the area of a circle, and they tell you the diameter. Well, let's figure out what the area of a circle is. It's pi r squared. So if they give you the diameter, you're not going to put that number in here. If the diameter is 20, then what we want to find is the radius. Of course, the radius is half of the diameter, so the radius is 10. That's the number we're going to use. So area equals pi times radius squared, which is 10 squared. And that's 10 squared is 100. Pi, you can just do this in your head. You don't need a calculator for that. I think I can even do that. So 3.14 times 100 is 314. Now if you want to take it out another decimal place, it's 3.1415, and that 5 rounds the 1 up to a 2. Or if you want to use it in a calculator, you can as well. It's in feet, so area is feet squared. That's all there is to that. Just remember to change it to radius.